Hello, my name is Emerald Aguirre, and I will be discussing some of the foundational terminology utilized in data analytics. Specifically, the concepts of reliability, validity, and standard deviation, as well as the type 1 and 2 errors that can arise in data analysis for psychological research. Reliability as well as validity, which will be discussed shortly, are two concepts used to evaluate the quality of research. Reliability, in particular, is the extent to which the results of a study can be replicated under similar conditions. There are four primary types of reliability in research. Inter-rater reliability, a measure of the consistency of the same test by different people. Test-retest reliability, a measure of the consistency of the same test over a period of time. Parallel form reliability, a measure of the consistency of different versions of a test which are designed to be equivalent. And internal consistency reliability, a measure of the consistency of individual items on the test. While reliability focuses on how reproducible a test is, validity focuses on the accuracy of the results of a study. Validity is essentially the extent to which the instruments that are used measure exactly what you want them to measure. The subtypes of validity include internal validity, which is the degree to which a study provides causal information about behavior. External validity, the degree to which the results of a study apply to individuals and realistic behavior outside the study. Face validity, the degree to which a test appears to measure what it claims to measure based on face value. Content validity, the degree to which a test is representative of all aspects of the construct. And construct validity, the degree to which a test is an accurate measure of interest. In many cases, the higher the external validity in a study, the lower the internal validity. Validity is a critical component in research since it measures the accuracy of the result as well as the extent to which assumptions, correlations, and relationships from data can be made by researchers. One of the most common illustrations of validity and reliability is, of course, the dartboard example. As you can see, a reliable test may not necessarily be considered valid, while a valid test may not be reliable at all. To ensure that a test or technique is reliable and valid, it is important to develop procedures to reduce the possibility of potential threats and apply an appropriate statistical analysis based on the research question, target population, sample size, and research design, among other influential factors. To determine which statistical tests are most effective, it is necessary to first understand the type of data that is most useful for a specific research topic. Descriptive statistics, for instance, describe or summarize a specific dataset and include measures of central tendency, variability, and distribution. This type of statistic is used to help explain already known data relating to the sample or target population, while inferential statistics are used to draw conclusions, comparisons, causal relationships, and test hypotheses. For example, if, let's say, researcher Lee decided to investigate student grade point average at X high school and gather data based on the grades and exams from a random selection of students, she could then average the values to determine a general idea of the student's mean academic performance. She could even go a step further and determine the standard deviation, which is a measure representing the average difference between the scores and the mean of the distribution. So, a standard deviation basically explains the amount of variation of a set of values. It can help researchers make inferences about larger populations. This information can be helpful if researcher Lee were perhaps looking at the academic performance of different high schools. While one high school may have a higher mean test score, it doesn't necessarily mean the students are more intelligent. In fact, the standard deviation may be higher, suggesting the distribution is skewed, and students are scoring toward one extreme or the other, possibly due to some other factors like school displacement or transition to online learning that could have greatly impacted test scores. Okay, I've discussed a little about how descriptive statistics can be used. Let's consider how inferential statistics may be applied. Let's say researcher Lee has decided to test for the coronavirus among students based on mild symptoms. In this scenario, the null hypothesis could be the student's test results is not positive for the coronavirus, and the alternative hypothesis could be the student's test result is positive for the coronavirus. In this case, there are two statistical errors that can occur. For example, the test results could say a student has the coronavirus when they actually don't, which would be a false positive conclusion, a type 1 error. This would mean the results appear statistically significant when they actually occurred due to chance or some unrelated factor. On the other hand, the test results could say the student doesn't have the coronavirus when they actually do, which would be a false negative conclusion, a type 2 error. This means the effect was not detected, likely because of statistical power. While statistical error can sometimes be unavoidable, the risks of these types of errors arising can be minimized through careful planning of the study design. In closing, I want to leave you with a quote. Statistics is the grammar of science. Indeed, without developing an appropriate understanding of the concepts and terminology used in data analytics, it would not be possible to effectively interpret statistical tests and communicate the data necessary to continue advancing psychological research. Thank you for your time.